Good afternoon, ladies and gentlemen. Today, I wish to introduce some major development that I managed to achieve today. The progress I've made today is very significant and does have a lot of implications for further development. However, there's still significant challenges ahead, and it has to do with reducing the computation of these movements so that it is easier and faster to handle. So presently, what I have is 900 cubes laid out in a two-dimensional fashion, and I'm going to create displacement on them. So I already have done the computation and the keyframe settings in order to make this possible. I'll go over it in just a second. But now doing this computation over 900 cubes, it takes about maybe a minute and a half, maybe 2 minutes for it to compute. And then I can do the further steps after that. However, in the interest of making this a viable system, I would need to be able to do this or same system, but apply it on more than maybe I want to say 2,000, no, more than 2,000. It has to be something like 10,000 cubes. So it has to be 10 times as big as this for it to be effective in the way I want it to be effective. Still, so this is still the first few steps, but still this is significant. So let's play the animation so you can understand what I'm talking about. So you can see here that the cubes are moving in space according to predefined patterns. So this is what I call pixelated displacement. It's a function here in the panel name here. So what this does is it utilizes a shape in 3D space like a mesh, like the monkey head, or this is a collection of leaves, which I'll show you in a minute. And it creates a ray tracing test in order to identify the distance from the original plane, and then it displaces the cubes according to their intersection with that mesh. This allows me to create this kind of three-dimensional map, and then I can relate these points using skeletal webbing in order to create the shape. So now, because it's pixelated on that level, the skeletal webbing is not effective enough to recreate the mesh, although this is what will happen eventually. It's just I'm going to have to work on the skeletal webbing in order to reproduce the mesh afterwards. The reason why this is important is because when it comes to trying to create 3D millable mural sculpture, so imagine a scene of Christ in a church wall or something like that, or say I want to create that as a milling file so that I can put it on like I don't know, some cool Dane axe head or some ornate weapon of war type situation. If I want to produce a milling pattern that will be millable, there are certain parts that have to be edited so that instead of having characters with their limbs be out in 3D space, it has to be in a it has to be in a mural format, so that it's elevation only and does not have a gap behind the limbs of the character to the background. So that kind of thinking will be possible using this type of system in order to produce the milling file. So that's why this is important. I'm still working on skeletal webbing in order to have the final file that I can then use for milling. But this is a significant step because this allows me to identify the coordinates in space on which I can then do the webbing. So then I can process any shape or any file and then have this pixelated displacement be done so that I can identify the right points necessary to translate it into a mural. So let's go into the animation here. You'll see the keyframes. So I just set two different keyframes in here. Well, it's more than two, but it's two different objects. So the first object here is the monkey. So I'm just going to show that to you so you can see it. So I put the monkey in place, and then I had the pixelated displacement be applied so that the cubes move to their place. Now you can recognize the shape just by looking at it with the displacement. And you can see how that's done. And then the other one is the leaf, which is this is the pattern of leaves, and you can see that it creates this intersection with the object. Now, although this seems like a simple idea, it took time and effort and many failures. It is kind of amazing how many failures happen considering the simplicity of this end result. Yeah, so this is still one of the early steps. I have to develop much more about this, but I think you can intimate a little bit about where or how this could be utilized. This, I think, is a significant step forward and will enable me to accomplish things that were not possible before. So I'm going to add here, I'm going to stop this animation. I'm going to go here so that I can demonstrate the skeletal webbing in action. Now the skeletal webbing is not completed yet. I just have accomplished the first initial stages of skeletal webbing, which do function accurately, but they do not consider all the parts accurately. So there's a lot of definition and logic that I'm going to have to work on for the skeletal webbing. Anyways, if I go into skeletal webbing here, I've got a few options. I'm going to go for a perimeter mesh. This one will create the simplest mesh with no intersection, so it will not take into consideration all of the parts, but rather the extremities to create a contiguous mesh. So you can see here that it is not taking into consideration these inner cubes here to create a more accurate representation of the cube head, but rather it creates a perimeter mesh with the extremity values being considered. If I use just this perspective here, you can see that all the webs that were created in order to generate the mesh. Now it is close to the monkey, but it is not exactly it. So it will take some time in order for me to be able to match this initial mesh with more detail. But once it will be completed, it will be possible to create objects from initial meshes. It will enable you to simplify meshes through this process, so that if you have a very large amount of vertex or vertices, it will be possible to reduce them through this kind of voxel system type thing. But it's not exactly voxel; it's a much different logic. So that's going to be in the line in the future. So you can see that it did represent a little bit of the curves of it, but in a pixelated fashion. So eventually I want to be able to scale this so that instead of having, say, here is this full grid is 1,000 cubes, I would like to have 10,000 cubes instead, so 10 times as much. However, the computation requirements for this exceeds my system. So my computer is not able to create this. I mean, 900 is already close to the limit. When I launched the pixelated displacement on 1,000 cubes, it takes me about maybe 2 minutes, maybe 5 minutes, depending, to get all the values and the corresponding displacement. So I'm going to have to work on simplifying that. However, I do think that this is a significant step forward. And I can also go like this, and I can select those, and I can do the skeletal webbing. However, these ones are all on the same plane, so I don't think I'll get something functional. Yeah, see, this doesn't make sense. So, however, I can go here and I can select, say, only. This would be the equivalent of one leaf, and I can go do the webbing. So you see something of a leaf comes up, but this is not really effective. So I'm gonna have to change a little bit the logic so that this is possible. However, this methodology is quite novel, and it did take a lot of effort to realize. Now its implications are very vast. You can do a lot of things with this. This is just the initial stages. You'll see eventually this becoming absolutely magnificent. I can basically utilize any 3D printed mesh to create this stylized perspective on it, which is going to be something amazing. Anyways, so that's going to wrap it up for what I wanted to express today. Thanks for your time and attention, and I'll see you guys soon.